Hey, I want to thank everybody for joining us for today's webinar entitled How to Achieve Complete, Robust, and Scalable Lab Integration, Data Management, and Visualization. Today's session is sponsored by Astrix, and it is presented by Burkhard Schaefer from Splash Lake, who we'll introduce in just a moment. Before we go into today's content, I'd like to take a moment and just give you a quick introduction on who Astrix is, as we're sponsoring today's session. So just a little bit about us. So Astrix, in its simplest terms, we are a consulting company. We are a life science technology consulting company specifically, and have been doing it for the better part of 28 plus years now. We work globally. We have offices in Europe. We have offices in South America, Central America, and the United States. And we help customers with a very unique blend of specialized strategic and technical services, processes, as well as a technology agnostic approach that has given us a stellar reputation in the industry in helping to transform the way life science companies organize their R&D around digital transformation. 90% of the folks that work for Astrix, and it's over 1,000, hold advanced scientific degrees. So that's something we're very proud of here. We're very much a science-based organization helping other science-based organizations. So that's just a little bit about us. I'd like to take a moment now and introduce our speaker for today. Burkhard is going to be presenting. He's a managing director at Splash Lake. Over 25 years experience. He started working in instrument control, data standards at Los Alamos National Lab, and later at the National Institute of Standards and Technology. Burkhard, I don't need to read your stellar background. You can certainly pick it up from here. I'm going to sit back and enjoy the presentation with the rest of the attendees, and we will come on at the end to help with Q&A.
Thank you very much, Kevin, for the kind introduction, and thanks to all of our friends and colleagues at Astrix for hosting us today. And today we want to deep dive into how Splash Lake sees the world of lab integration, data management, and visualization, and talk about that a little bit. And this has obviously been done for quite a while, but we're all struggling with similar similar questions. So how do we do this at scale? And we want to talk a bit about the Splash Lake approach of how we can get lab integration, data management, and visualization working in a robust way, in a scalable way, and hope you'll enjoy. So the typical challenges we see in digitization projects in labs is typically at least these three. So the first one being lack of connectivity. So we have these beautiful leading systems, whether it's LIMS or ELN or SAP. We also have really good instruments, but there is a lack of connectivity between the two. So that means there is a lot of manual effort that needs to go into moving data across. And it also means that data is left behind because you cannot transcribe everything. So here we have a major pain point. The next one is we are talking about disparate data. So we are facing different data types and data formats. Every vendor has a different data format. And now we have that data scattered across multiple systems. And that includes instrument systems. It includes LIMS, ELNs, data lakes, you name it. And not only does it make it hard to use the data, it also makes it hard to locate it in the first place. So how are we doing that? How can we find the data? And how do we bridge the data format gap? And all of that leads to this problem of lost or inoperable data. And we also like to call that dark or orphaned data that is hard to find, hard to reuse, and it's limited to the original system. And because it's typically not contextualized, it's even harder to make that data findable and reusable. So what do we need to do to solve all this? Well, there are three things. If I have a lack of connectivity, wouldn't it be nice if we had a scalable way that allows me to connect instruments to those leading systems using repeatable patterns? And here we need a proper approach for data management that goes beyond just collecting files. It's about collecting all the different data types that are relevant in the lab today. And the question of lost and inoperable data, well, that is where we need content awareness, when we not only should be collecting the data and throw it into one big bucket, it's what we can do from there. And that's important that we understand what that content does, and we understand all the data formats, and we can then do sophisticated things on top of that. So when Splash Lake looked at these types of problems, we said, well, there are some things that we can do about it. So let's pivot over and look at what Splash Lake does in that space. So we see Splash Lake as a refreshing approach to your scientific data journey. Yeah, so you see, it's refreshing, it's about scientific data, and it's a journey. Yeah, and that's intentional. And because we believe that there needs to be a refreshing way of doing this, and you're never done with your scientific data. It's always a journey, because we think that we can get more and more value out of the data that we create, especially with artificial intelligence and machine learning capabilities now becoming more accessible. We need to have a proper data layer in place, and that data layer needs to be multimodal, so it can handle all the different types of data that we talk about, and it needs to be productized. And it needs to be scalable. And that's the Splash Lake approach. And Splash Lake tackles three different spaces to support that. So the first one is instrument and system connectivity, where we have a rich and vendor-neutral solution that connects leading systems such as LIMS, ELN, SAP to instruments in a repeatable way. And it does that in a way where I don't have to write lots of parsing scripts and configure my workflow engine and so on. But it's based on patterns, and it's about getting these things in place at scale. So not only are we handling the data in flight for the integration, but we could also give that data a home, which is where we talk about the second area, which is exceptional data management. Splash Lake can provide a home for that data, and that means not only files, it also means time series data, it means metadata, it means chemical structures, all held together by metadata with proper governance. And there is an automated way to collect data, to process it, and to safeguard it for the long term, and then to have proper data analytics on top of that. Which takes us to the third pillar, which is data to value, or data value creation, where we are able to create interoperable data packages that contain all the data, but then to also run data analytics on top of that, and making that data useful outside of the original system by normalizing it into common data formats, and by then having appropriate common ways of processing that data in a rich experience. And one big differentiator in the market space to us is, yes, you can store the data in Splash Lake, but we don't force you to migrate all of your data to us. We're very happy for you to bring your own storage, and you can leave the data in the systems where it's already at, or you can choose to actually put the data into Splash Lake if you want a fully managed approach. So this is probably the most important slide if you want to know what Splash Lake does. And give you a bit of a history. We've been doing this for over 15 years. Vendor-neutral data management started under the brand name of BSSN Software. Were acquired by MilliporeSigma, now operating as Splash Lake since 22. And we serve both end-user industries in pharma, biopharma, material science, consumer goods, chemicals, food and ag. But also, we're a partner of our friends in this industry, where we supply software components to LIMS vendors, to instrument suppliers, and we have a couple of joint products on the market where sometimes you see our name on it and sometimes you don't. If you look at the overall picture of lab informatics and the role that Splash Lake plays in such an informatics ecosystem, we see a couple of key components. The first one being instruments and equipment, where you have a way of talking to them, and obviously depending on the type of instrument you have, the last mile to the instrument will look different. Then on the other end of the spectrum, you have leading systems, which could be your LIMS, your ELN, your SAP, an MES, a SCADA system, and so on. And these systems typically cause work to be done in the lab, and then that work will be done partially by end users and partially by instruments and partially by high throughput robotics and so on. And then at some point you have storage, and that storage could be cloud, it could be local on-prem, or it could be existing systems such as an SDMS that you might already have, and it might be an S3 bucket over here. And Splash Lake brings all of these things together, gives you one common view of that data and that metadata, and then you can get work in from those leading systems, which could be test requests or experiments that have been designed and planned over here. And those then make it over to the instrument, where we can then control the instrument. We can send sequences down to instrumentation such as CDS, or we can control equipment. We can generate run files for robots. And then when the data is being generated, we can bring that in. But at that point, we not only bring in result files, but we also bring in things like time series data, we bring in metadata, but also operational data like logs and telemetry and live update of instrument status. So you have a holistic view of what's going on at the edge. And then we can take that data and we can push it on to the leading system, which could be the same system that generated the request to do the work, but could also be other systems that want to have a record of that. And yeah, all of that data is safely stored in a compliant shell. And then you have a lot of ways of browsing and interacting with that data in an automated or also in an interactive way. So let's now double click on these different pieces. The first one being the instrument and system connectivity, and then we'll go on to data management, and then we'll go on to the data analytics and data reuse. So first of all, instrument and system connectivity, that's a big challenge. And it's a challenge because primarily folks are building individual interfaces for each of the instruments that they have. And if you look at, okay, these are some of the instrument types that Splash Lake supports out of the box. We support several hundred instrument models out of the box using our connector and data transformation technology. So starts with analytical chemistry, chromatography, spectroscopy, mass spec, NMR, goes all the way through the biologic space with bioreactors, both large and small, and purification chromatography, cell counters, bioanalyzers, Western blots, and so on. And it goes all the way to things like balances, pH meters, refractometers, and so on. So it's a technique agnostic approach, and it's a vendor neutral approach. And if you connect an instrument to Splash Lake, the first thing that we're going to do is we're going to look at, okay, what does the last mile look like to talk to that instrument? We're then going to normalize that content so you can easily consume that content in whatever system that you need the data to go into. And I'll give you a couple of examples of what that can look like. This may actually be familiar to a typical lab workflow. So you could start with something like a balance, where you say, okay, yeah, this is actually quite a simple instrument. Well, it's not. There's one thing that a balance does not typically tell you what sample is on top of it. So you need to add context to that. And Splash Lake lets you do that. Once you've weighed in your sample, let's say as part of sample prep for chromatography, we can actually take that weight and transfer it directly to a sequence table. So we cannot just send that back to the leading system where we got the job from, but we can also send it to peer instruments that participate in the same workflow. So you weigh in the sample, and that gets into the sequence table of the CDS with just one press of the button, and that's quite nice. We can also handle other aspects of sample prep. So we support liquid handlers, both robotics, but also handheld pipettes. So we can scale this up from low volume to large volume in terms of sample throughput. We can work with all kinds of chromatography data systems where, for example, here we've worked with Thermo Fisher to build nice integrations with Chromeleon, where you have, in this case, it's Chromeleon, and if you connect Chromeleon to Splash Lake, it actually gets all of that data in, and you have a very, very complete record of all of the raw data, all of the results, all of the peaks. All of that is interactive. And yes, we have the full instrument method in there as well. And that data format is the same as you would get for a different CDS. So for example, with our friends at Agilent, we've done a similar thing with OpenLab CDS2. If you put that with Splash Lake, then you get a similar story, so that you then are in a position to reuse that data in many different ways. So we're really looking for the depth of integration and not just collect, five numbers from a run, but we want to give you a very complete data set, because that is more suitable for machine learning, for data analytics, and so on. And then obviously that data can go into a number of different systems. And we have a large ecosystem around LIMS and ELN. And we frequently host these interoperability showcases at trade shows. So maybe you've already seen some of these at the typical conferences where we showcase the integration together with our friends in the LIMS and ELN vendor space. And we actually have some real live equipment on the show floor that you can then talk to using these instruments. And getting the data in and out is quite easy. We have a couple of ways that you can then do that. So you can install agents on the instrument PC. And we also have deep integrations with some systems where you actually can press buttons on the toolbar of the CDS, for example, to get your data approved and then sent to Splash Lake and on to LIMS. And the key differences that we see at Splash Lake is we offer vendor-neutral connectivity to almost any device. So as long as it has some type of a digital interface, we can talk to it all the way via the cloud or via something as simple as RS-232, USB, you name it. We not only capture results, but it's a complete transfer of data and associated metadata. So you have the context around your tests and your samples. We can work in a bidirectional manner, so you can create and update work lists on the fly and send those directly to instruments. So beautiful sequence editor, for example, for chromatography work. And we support all kinds of data types and formats. So whether it's files, time series, simple instrument data, metadata, relational data, and so on. Whether it's standard protocols or text or binary or CELA or animal, we really like to look at these different capabilities to the last mile. And all of that makes it a scalable approach because we see our library of instrument adapters as products. Yeah, they are maintained with a proper life cycle. We are not just writing parsing scripts, right? This is a product, and so if there's a new version of the instrument software, we have your back in terms of supporting any changes to the data format, and you can raise a support incident if you need help with that. So that's how we see instrument integration and how we can take that to a new level, because it's easy to do that with 5 instruments. It's hard to do it with 500. Yeah. So how do you make that transition? And that's where it really requires rethinking doing that. Yeah. And if you work with a player that has a handful of connectors and that will be happy to custom build stuff for you, that's not going to get you to a scalable ecosystem, right? And that's where Splash Lake has a much more scalable approach. So as we said, Splash Lake not only handles the data in flight, but can also make sure that that data goes into common places. And that's where we offer a holistic view of doing that. And key differentiator for us is here that we look at this in a multimodal way. What does that mean? Well, we have all different kinds of data that we need to look after. So if you look at files, and if you only had files, you would consider a system such as an SDMS, right? So you would store your instrument files in there with, which could be the raw data, the process data, reports, and you would have your versioning and audit trail. Yes, that's fine, yeah. You can also do that with Splash Lake. You can even keep your existing SDMS in the background, or you can use an S3 backing or so. We don't care where it sits, but we're happy to manage it. But that's not enough, right? Because today we have so many more modalities, because we call them streams. We have time series data, which could be environmental sensors, which could be bioreactors, which could be your freezer monitoring, or even energy and power consumption. All of these give you time series data. So this is not a file, right? You turn on the sensor and it never stops. It gives you a new value every couple of seconds. So how do you deal with that? Well, we cover that as well. Then we capture metadata, and that metadata goes across all the other modalities as well. So you define the entity that you care about, whether it's a study, a batch, a product, a compound, or even the HPLC column that you used. We can get that data, that metadata in place either through automated extraction or through manual annotation. We can also tap into any relational data source to provide context and to provide navigation in one place. So anything that sits on top of a database can be a metadata source and can be a source of context within Splash Lake. And that is really, really powerful. We also support chemical structures. So if you have compound databases, chemical libraries, or a database with your synthesis routes, we can tap into that. We have full structure search, and we can annotate analytical data with chemical structures. That's quite powerful. And then there are the simple instruments of the world, so balances, pH meters, conductivity meters, and so on. And they can play together in such an ecosystem as well. And we think that if you look across these different modalities, only then you can really tell the whole story. Yeah? And that complete data we feel is exponentially more valuable than just focusing on one of these. And that's where we see a key differentiation in our data management capability, because that complete data provides the full story and it holds significant future value through AI and ML. Because if you have this as a baseline, then you can have fun on top of that. But for us, it also means we need a shell of compliance around it that is also multimodal, so that we can handle permissions and audit trailing and archival, but also backup and disaster recovery. And to do that in a validated environment and also in a non-validated environment. If you now look at a typical lab workflow, it starts at a request that might come in from a LIMS and ELN. Then you might have some sample prep that includes weighing in and diluting and stuff, preparing your sample. Then it might include work list creation, sending that to the instrument. You acquire the results, you send it back to the LIMS and the ELN, and then you capture the data, you make it ready for archival. At some point, you might get a request for audit or reprocessing or inspection purposes. You might get some reprocessing, and at some point, you do the data disposal. And Splash Lake can handle these bits in a multimodal fashion across these data types and keep full track of each and every data point on the journey. And we'll show you what you can then do with that data. Because that takes us to not only having a very complete picture of your data, but now you also need governance, right? You need to be able to find all that, and you need to make sure that you have all the right things together. And so if we look at the different data sources that play a role here, we've already alluded to some of them. We're talking about the usual suspects like ELN, LIMS, and CDS, your relational databases, your proprietary files, instruments, web services, and so on. And what Splash Lake can do is three key things here. The first thing is we can do real-time lookup into those data sources. So at the time of use, we reach into those original data sources, we pull the things out of. Then we can do real-time data conversion. So as soon as you access a proprietary file, we can normalize it at the time of access so that you can work with the data regardless of the original format. And we support a number of data standards such as animal and others in order to do that. But you can also define rules of how to do data extraction ahead of time. So you can pull that data out of instruments, and you can then use that for metadata, but also to do result extraction and to send that on to leading systems. And the key Splash Lake difference here is you can federate data and metadata across all of your data systems. We don't force you to move the data. You can leave it where it is, but you still get that full picture. And you get transparent data access across data formats because we blur the lines between those formats. That gives you complete data that is accessible from one place, but that doesn't have to live in the same place. A very powerful concept that makes it also very scalable. And this is great for future use, but also audits, being able to find your stuff when you ask for it. And it lets you generate rich and contextualized data sets that are ready for artificial intelligence and machine learning and data analytics applications. But all of that with appropriate access control, and that can those access control rules can be based on metadata and on roles and other things. A couple of things you can do now is we can control data ownership for instruments that are shared between multiple stakeholders, and that can be an open access scenario. It can be contract testing where you work for multiple customers, or it can be a CRO CDMO scenario that where you work for multiple sponsors. We're able to segregate the data from the instrumentation as it comes in so that it can be sharded based on which organization can benefit from that. That way you also have the full life cycle under the control of the regulations of that organization, and also a nice compliance story with handover to the other party and things like that. So quite interesting what you can do once you have that level of control. Also, there are many capabilities that make Splash Lake suitable for GMP and GLP environments. So we have a number of features that support the deployment in these compliant environments, and also the compliance expertise in our professional service organization. And obviously, we're also working with our partner Astrix here to deliver and to validate this for you. The must-have features, obviously, audit trailing, versioning, a permission system, auditable permissions, data review, approvals, and so on. We also have a controlled software development lifecycle and deployments. There are skilled professional services that let you do IQ and OQ as a service, but also some really smart features to make compliance easier. For example, the support for the digital archivist role, so that the archivist can really handle their processes in a fully digital manner, to do deposits into the archive and to do retrievals, and a nice way to consume the data that it has been deposited into the archive, and to also find it using metadata. Now, so far about data management, let's look at data visualization and data value creation, because we let you, now that we have the data accessible from one place, we let you leverage your data anywhere you need it. Because we think that we need to move away from that system-centric thinking, where I need to go to the original software to work with my data, to a data-centric thinking, so that data comes to me at my point of use, and I have everything at my fingertips, and I don't need to know where it came from. And that gives us rich instrument data, all accessible from one location. And that can be, again, multimodal. So whether it's time series data of this incubator together with power consumption, that comes one of those Wi-Fi plugs to measure that, all the way through chromatography, spectroscopy, bioreactors, and rheology, and so on. And we can work at the individual experiment level, but we can also create views across experiments so that you can see trends and things like that. And we have a very powerful vendor-neutral data review and rendering engine that can deal with about 24 measurement techniques, whether it's, again, chromatography, spectroscopy, image data, particle sizing, formulations, rheology, plate readers, and much, much more, all the way to microscopy data. All of that is possible. And if you have multiple measurements that are performed together, we can even keep track of the workflow that have led to that particular data set, and you can navigate along that workflow to see the individual bits. And if you then contextualize that and you've got some chemistry information, then that becomes even more powerful, right? Where we support access and annotation with chemical structures. So you can either have individual molecules or entire reactions. We support structure search. We have support for property calculators, and you can choose the chemistry engine that you prefer. And you can not only use that to manage your molecules, but you can also keep track of the context of the other things, because to us, chemistry is also metadata that you can use to annotate your analytical data, and you can link it to your samples, your synthesis paths. You can see, what do we know about this compound? Where has it been used? And once you have that multimodal way, it's also interesting that you're able to do data analytics. So there we have the possibility to pull together data from all of the sources. And we have very powerful Python notebooks where you can then define the kind of views and processing steps that you want to apply. And that can either be done automatically or it can be done interactively. And that gives you a very quick way of navigating and using your data. But not only that, we can also support you with operational aspects. So you have things like monitoring the power consumption of the individual instrument, or we can, with one click, open a remote desktop connection to the instrument PC, so that you don't have to walk to that PC if something goes wrong. We also have log aggregation, so you can ingest instrument logs and view and search them in a central place to see if anything goes wrong. There is also instrument status and telemetry, and we calculate the utilization so that you know how busy is that instrument. Do we need another one, or could this one go anywhere else? And we can monitor the integrity of critical configuration files so that you get alerted, for example, if somebody changes the method on an instrument. And there are a couple of analytical capabilities. So for each instrument, you can see what the open LIMS and ELN requests are to actually do something. And we can visualize the data without the original software. We can parse all kinds of data formats for several hundred instrument types. We can work with data streams and time series, and we can put that data all into one go. And so you have a convenient agent that ingests the data, moves it into central storage, and then triggers downstream capabilities. And yes, sometimes it's nice to also have a webcam to know what's in your incubator, or to see what's actually the sample that lives on the balance. So far about the operational bit, and this is also where we move on to the summary. So SplashLake is really thinking about how we can deliver long-term value to customers by focusing on a proven and productized approach to do data integration, instrument integration, data management, and data visualization so that you can achieve your implementations faster and significantly reduce the time to value. We want you to be able to scale easily, to add new instruments, new systems, new data sources. But it all comes down to this. We want you to be able to generate more value from your data. That's what we're about at Splash Lake, and that's what we've prepared for you today. So thank you so much for your attention, and I think we're ready to answer any questions that you may have, and I'll hand it back to Kevin.
Thank you, Burkhard. Great presentation, and thank you everybody for joining us today. A couple of things. If you have any direct questions of Burkhard, you'll see his email address up there on the screen, as well as a URL for Splash Lake. You can reach directly out to them, for any questions or follow-up that you might have. I will get the recording stopped at this point,